In this video, we'll be going over the lapse rates A6 question for the Lightning Lab. So the question for this one is asking, if we travel to a location in the geovisualization, and if the dew point is 9.5 degrees Celsius, what is the height of the lifted condensation level and air temperature 3,000 meters above the surface if the air is lifted adiabatically? All right, so in the PDF here, we've got the different lapse rates that you use for this question, okay? So when you lift air adiabatically, basically what that means is imagine an air parcel or a balloon at the surface with the air temperature inside. You lift this balloon up, and because the air pressure decreases as you go up in elevation in the atmosphere, the balloon is going to expand. And as the balloon expands, the temperature inside drops because the pressure is dropping, and so you're cooling the temperature inside of your air parcel, inside of your balloon. And the rate that this temperature drops is going to be dependent on the moisture conditions in the air parcel. Okay, so if the parcel is unsaturated, you cool at the dry adiabatic lapse rate. Right, so if the air parcel is not at dew point, it cools at the dry adiabatic lapse rate. That's 10 degrees Celsius per kilometer. Or in the case for our questions here, since we're doing 500-meter increments, it's 5 degrees Celsius per kilometer. Okay, and the wet adiabatic lapse rate is going to be used once you reach dew point, once condensation is occurring. Okay, and then the environmental lapse rate is going to be the temperature outside of the air parcel, and this is going to be variable depending on the time of day, depending on the season, and we won't really worry about this for this question. It'll be in later stages of this lab, so don't worry too much about environmental lapse rate for this particular question. All right, so what we want to know is what is the lifted condensation level. The lifted condensation level is the height that an air parcel needs to cool to in order for clouds to form. Okay, so we need to figure out what's our lowest height for clouds, what's our cloud base, and then what's our temperature at the top of our column of air. So we're going to this location in Flagstaff right here. I have a screenshot from the geovisualization. And the air temperature is 24.5 degrees Celsius. So we have 24.5 degrees Celsius for our starting air temperature, okay? Our dew point is 9.5 degrees Celsius, okay? So since we're not at dew point, since the air parcel is not saturated, we use the dry adiabatic lapse rate, okay? So that's gonna be 24.5 minus 5, which is 19.5 degrees Celsius. Still not at a dew point, so we'll keep on cooling. Okay, so 14.5 degrees Celsius, still not at dew point, so 14.5 minus 5 is equal to 9.5 degrees Celsius. All right, now we are at dew point. Our dew point is 9.5 degrees Celsius. So what's currently happening then is our air parcel, which down here is water vapor. There's no condensed liquid in it. There aren't any clouds. Now it's forming some clouds. And what happens when this occurs is something called exchange of latent heat. Latent heat is just a fancy word for what happens to the energy when a stage of water changes phases. So if it goes, in this case, it goes from a gas down into a liquid. When that happens, the higher energy gas has to give off some heat. Those molecules have to give off some heat into the air parcel. Okay? And so instead of cooling at the dry adiabatic lapse rate, we've got a little bit of heat now added into our parcel. So instead of minus 10 degrees Celsius, it's going to be minus 6 degrees Celsius per kilometer, or 3 degrees Celsius per 500 meters. And so because now we have condensation occurring, this is our lifted condensation level. this is the height that clouds can start to form in our air parcel. So since we've got clouds forming, instead of cooling at the dry adiabatic lapse rate, we're going to continue to cool at the wet adiabatic lapse rate. So 9.5 minus 3 is equal to 6.5. And then we keep on going up. Okay, so then by the time we reach 3,000 meters above our starting height, we've now cooled to 0.5 degrees Celsius. We changed our lapse rate when we had condensation occurring. So when we're trying to answer our question, what is the height of the lifted condensation level? It's 3,565 meters. And our temperature after that phase change, by the time we get 3,000 meters above, is 0.5 degree Celsius.